Thank you for joining me again. I remain your own friend, edu-aider. Thank you for joining me on my YouTube channel again. Please don't forget to always subscribe. Just subscribing, you subscribe. You like? Of course, you can make a comment. So make comments. Comments now. More than one. Any observation, make it known in the comment. Any question, make it known in the comment. Any recommendation, make it known in the comment. Anything, make it known in the comment. I will reply. Thank you for joining me. Quickly, we continue with our series on the application of differential calculus. And under this, we've spoken about the gradients, something as slope of curves of functions, and how we can determine and solve questions on them. Now we're talking about the minimum, maximum, and inflection. Let's look at this. We have this. This is, of course, was y. The negative y-axis, or positive x-axis, the negative x-axis. Let's say we have this. I will name this A. I will name this B. These are points, be A, point B. I will name this point C, while I name this D. A and B implies what? The maximum points. You get? So this, of course, this is a graph. So produced as a result of a particular function or a curve, something. So this gives this kind of graph. So these are the maximum points. While D, it implies the minimum points. Then we have C. It is the inflection. Now, these things are different. There are different times to use them. Please get these meanings. These are maximum, of course. We say, oh, when the value is very big to an extent, correct? But you must know when you use them. Like this. Now, let me call this if. The conditions. If you are to draw the graph, let me first start with that. If you are to draw the graph, like you have a curve or a function, and you determine the maximum point and the minimum point such that you sketch the graph, this is what you do. You consider these points. If the square y dx square is, okay, let me write this. If 1, the square y dx square, I want you to see this very well because this point is important. If 1, the square y, the x squared, that is the second derivative of that function, is negative, then it is maximum point. 2, if the square y, the x square is positive, then it is minimum point. 3, if the square y dx square is equal to 0. It is inflection. What does that mean? Inflection means is a time or a point where it is not maximum and it's not minimum. That is, your second derivative of the function you are dealing with is giving you 0. That's inflection. Am I communicating? So these are the conditions when you have to deal with graphs. Now, there's another condition. This condition is very, very important. Let me note it here. Note it here. You notice another important. If you are looking, for example, just a function you are told to calculate to solve for the minimum value and the maximum value, you watch out. At the turning point, don't forget. When you find, like when we did for the gradient, after finding the gradient normally you equate to 0 if you are not given the value of the gradient, isn't it? So at that turning point, you consider the turning point. That turning point will be equal to 0. So at the turning point, if, okay, let me call this condition 2. At turning point, if x is bigger, it is our minimum point. But if x is smaller, it is a maximum point. Please note this information. This is condition 2. This is condition 1. Yeah. This one you need to deal with sketching the graph after work calculation. This one you don't need to sketch the graph. That's for condition 2. You just go right away. Let's take some examples. Yes. Let's take it on with some examples. Now we have this question. It said, find the minimum value of the function two x squared so x cubed minus 6x squared. Let's solve. Now, this is just to calculate the minimum value of this function. So you use condition 2. Do you get it? So the first thing we do, we find out the y. Let's take this because this is f of x. Everything is equal to y. Of course, y is equal to this. So we say y is equal to 2x cubed minus 6x squared. Then the y, the x, can be equal to 6x squared minus 12x. Now, we say at turning points, the y dx equals 0. So you can say 6x squared minus 12x can be equal to 0. And of course, this becomes a quadratic equation. So what do? If I were you, I would decide to first divide through by 6 because 6 is a factor here. So if I divide through by 6, I have x squared minus 12x, minus 2x can be equal to 0. Yeah. So I can actually go through ways. I can say I can factor this out. I have x open brackets, x minus 2 can be equal to 0, which implies that x can be equal to 0, or x can be equal to what? 2. So here at this point, I can now work on my minimum value of this function. So what is my minimum value? I said in condition 2, if the value of x is bigger, that will determine your minimum point. So this now go for minimum. Minimum. This, the smaller, goes for max. Maximum. Do you get? So now we can now use this to calculate for our minimum point. So here, which means x is this. We bring it into this equation and we say y. Let x be equal to 2 in f of x. These are f of x. So we can say y can be equal to 2 open bracket what? 2 raised to the power of 3 minus 6 open bracket 2 raised to the power 2, and that can be equal to these 8 times 2, we have 16 minus 24, and that will be minus 8. So the minimum value of the function is minus 8. You get? So let's go. We have another question quickly. So this one says, a swimming pool is treated periodically. It is treated periodically to control harmful bacterial growth. The concentration of bacterial per centimeter cube after T days, as T particular number of days, is given by C of T, which is equal to 30 T squared minus 20T plus 500. In how many days after treatment will the concentration be minimal? So that's why this concept or this aspect of differential calculus is known as the application of differential calculus. So this is one of the things we apply differentiation of calculus to solve. Yes, it says the swimming pool is treated periodically to control harmful bacterial growth. The concentration of bacteria per cm cube after T days is given by C of T is equal to this, which implies that C is what? Is the dependent variable. YT, of course, is the independent variable. So we're in how many days after treatment will the concentration be minimal? So what we have our C to be equal to 30T squared minus 20T plus 500. So what does that mean here? All we are doing here is what? We are differentiating. So the C dt will be equal to what? 60T minus 20. So for us to be minimal, we calculate, we look for the turning point. And at that point, it should be equal to 0. So the C dt will be equal to 0. And that implies that what? 60T minus 20 can be equal to what? Be equal to 0. You get that? So here, what do we have? 60T can be equal to 20. So what do we have there? You divide both sides by 60. Let's cancel this. So T. So 1/3. So that's like 1/3 of a day. So that is the solution to that very question. So here, I think we are supposed to have, there's a mistake in that question because of the number of days I'm having. My T should not be days. I think I have an error with the value here. I have 240. So if I have 240, this is just 240. So this so 60T minus 240 can be equal to 0, and that means 60T can be equal to 240. Dividing both sides by 60 with 240 divided by 60. You have this by 60. This cancel out this. This cancel out this. Of course, T will be equal to 4 days. So we have T number of with 4 days. Let's treat example 3. Yes, a very, very important example here we are treating. The third example is very, very important. I think I may have to even clear this. And space. So the question says, find the minimum maximum values of the function y equal to 2x cubed minus 3x squared minus 12x plus 8. Let's solve. And it says, hence, sketch the curve. So we are told to sketch the curve upon calculating. So here now, let's go for condition 1, like I explained. So how do we go? Find the minimum and maximum value. Of course, our y is this. First, to find out the y dx, which will be equal to 6x squared minus 6x minus 12. Yes. I now said something here. Here, we're supposed to find our what? Find the turning point. So as turning point, of course, the y dx should be equal to 0. So I have 6x squared minus 6x minus 12 equal to 0. Dividing 2 here by 6, I have x squared minus x minus 1 equals 0. So let's factorize this. Let's factorize this. What are the values that we are going to have? What are the values we likely have? Okay, factorization method. My product here is minus x squared. My sum here is minus x. So what are the two numbers that we're dealing with here? Oh, sorry, it's supposed to be minus 2. Yeah. So I have minus 2x squared. So I have minus 2 plus 1. Minus 2 plus 1. I think, yeah, that will give my problem, solve the problem here. So I have x squared minus 2x minus x, okay, plus x, then minus 2 is equal to 0. Of course, to solve this, so I have minus 2 plus 1, and that will be implies that my x will be equal to, that implies that my x will be equal to 2 and minus 1. Do you agree? There's a video I made on factorization, solving quadratic equations by different methods, factorization, completing the square, and general formula method. It's on my channel, Mathematics with edu-aider. Check my channel, you will see topics, you will see them there. So here we can see my x is 2, or so I have x to be equal to 2 or minus 1. That's the first stage. Then you go d square y dx squared. Because we are sketching a curve, I would have used this straight away to get a minimum value and maximum value. But I'm going to be sketching a curve, so I need to go by the condition 1 I gave. So here I have what? D square y dx squared. That will be equals to what? This is my dy dx. You gave me this, right? So d square y dx squared will be 12x minus 6. Do you get? So at x equal to 2, what do we have here? D square y dx squared will be equals to 24 minus 6, and that will be equals to 18. It is 18. Good. Because it is 18, what does that show? The value of the square y dx squared here, we say another condition 1, that when our d square y dx squared is negative, it's a maximum value. When it is positive, it's a minimum value. Here, this shows that we have a minimum value. Do you get? Now let's substitute this value of x in this original equation, rather in y. So that we get the coordinates for that minimum value, for that at that point where it's having a minimum value. Do you get? So here let x be equal to 2 in f of x. Don't forget, this is our f of x. So we can say y will now be equal to 2 open brackets. This is just 8 minus 3 open bracket of 4 minus 12 open bracket of 2 plus 8, and that can be equal to 16 minus 12 minus 24 plus 8. 16 plus 8, that is 24. So this gone. So y will be equal to minus 12. So the coordinates there will be 18 minus 12. Do you get that? Good. Let's treat at point minus 1. At point at x equals to minus 1. What do we have? D square y dx squared can be equals to what? The y dx is this, right? So we have 6 open bracket minus 1 squared the square y, sorry, I made that mistake. 12 open bracket minus 1 minus 6. And that gave me minus 12 minus 6. That become minus 18. Here, it is minimum. Let me note that. Here it is minus 18, it is maximum. So now let's x, since at x minus 1 for the square y, the second derivative, gave us the maximum value. Let's also put this in our function of x. Let x be equal to minus 1 in f of x. So what do we have? We have y to be equal to 2 open bracket minus 1, that is t minus 1, minus 1 raised to power 3 minus 1, that is raised to minus 1, then minus open bracket, okay, that will be 1, okay, 3, that's 1, minus 1 raised to power 2 is 1, so minus, so open bracket minus 1 plus 8, so that will be minus 2, minus 3, plus 12 plus 8. What we have, this is minus 5. Take away 5 from here, we have 7 left. 7 plus 8, 15. So y is equal to 15. So the coordinates x, y, that can be equal to what? Minus 18, then we have 15. Do you get that? So these are the two coordinates that we have. This. Are you getting this? So this is what we are supposed to sketch. Do you understand? We've gotten the minimum and maximum values. Now what we have to sketch is these two. Now let's sketch it. So if you have to sketch it now, we have, let me note this here. I want to clean everything. 18 minus 12. And I have minus 18, 15. Nothing perfect. You're told to sketch. So let's sketch that. So what do we have? Okay. 18 minus 18. That's beautiful. 18 minus 18, so I can go like 9, 18. Good. This, I can go this one 5, 5. Okay, good. So I have, so I can say from here, this is of course 0. Can go from here, this is 9. This is minus 18. This is 9. This is 18. Of course, this is a plus x. And here, down here, I need minus 12, right? So I can go 5. I want to go 5, 5. I want to go 5, 5, 5. So I have 5, 10, 15. This place taking as 12. Take that place as 12. Here, I have 5, I have 10, I have 15. So since I have 18 minus 12, 18, oh, this is, so I have minus, let me call this minus 12. So I have this 18. I have a point here. Then I have minus 18, 15. So let's say I have this point. You see that? So all I have to do, the first one, this gave me a maximum point, don't forget. So I can have a maximum point here. This gave me a minimum point. You see this? So I can just decide to join them. So I can have something like this. Do you see that? So this is exactly what we are supposed to sketch. This is what we are sketching. So you get the procedure. I've explained everything you need to know on minimum, maximum, critical points, gradients, the other, yes, virtually everything. So good, please kindly subscribe. I remain mathematics with edu-aider, mathematics with edu-aider. Share my link, my channel with your friends, with students, people that need them. Let them learn. Please subscribe, like, and comment. If you want to reach me, of course, you can reach me on this line, 234-8164-869470. You can reach me on WhatsApp with this. You can reach me on Telegram. You can reach me via call on the same line, of course. Thank you very much. See you some other time.